I'm Stephen Foskett, the organizer of Tech Field Day, and the video you're about to watch is a Tech Field Day presentation from November of 2016. We have invited a panel of independent writers and speakers from across the internet and around the world to join us here in Silicon Valley to meet with various companies, discuss their products, and learn about their technologies. Right now, you're going to learn about Igneous Systems. You can find out more about them. You can find them on Twitter, Igneous.io. You can go to igneous.io. And if you'd like to learn more about this event, just go to techfieldday.com or view more videos like this at youtube.com/techfieldday.
Hi, everyone. My name is Asif Daud. I'm the VP of Engineering at Igneous. And today I want to talk to you about how we deliver infrastructure software as a service continuously to these appliances. Before I get started, I want to talk to you about kind of the state of the art. I've been in this industry for over a decade, and there's a couple of big themes that have emerged in the way things are traditionally done. First one is the architecture. It usually is a single, large, integrated system that is incredibly hard to take apart and piece back together anytime you want to go make a change. Often it's an operating system image that when you want to go deploy new changes to it, you have to go and upgrade the whole thing. The second part of it is that in order to build this monolithic architecture and deploy it, it takes an incredibly long waterfallish process. It's started off by a bunch of horse trading around what features or bug fixes are going to go in, and then followed by long periods of building and trying to fix it all together. And there's a lot of consternation in figuring out what's going to go in because you have to get your features on this train, and this train leaves only once a year and usually late. Well, why is this a problem? What does this actually create for customers? The first one is obvious. It takes a really long time to ship anything. Regardless of the size of the feature, even if it's going to take an engineer a couple of weeks to build, you still got to get on that train, and it's going to take another year before it gets out there. It's incredibly hard to respond to customer requests. If somebody asks for a feature, again, you got to get in at the right time and get into the right roadmap, and again, take months to years before you get your request addressed. On the other end, if you have, say, a security hole in OpenSSL pop up, it's going to take a long time to get that fix deployed on all the different maintenance releases and branches and everything, and get it deployed again on your systems. When this big train finally arrives at the station, customers are concerned. The product teams have been spending 12 to 18 months piling in a bunch of changes in this. It's going to be a big, massive disruption to their infrastructure and their organization to take this change. And they have to do all the work. They have to go and convince all their internal stakeholders that, don't worry, it's going to be fine. We'll go schedule it and plan it all. It'll be OK. So this is clearly things that we wanted to improve on. These are mistakes we have learned, made in the past, things that we want to learn from and improve upon, and really apply a lot of the lessons that we have seen in other parts of the software industry, from the SaaS world, from the web world, and a lot of the hyperscale guys, as we've been talking about so far. So at Igneous, our goals are instead to go deliver features as soon as they're ready. We're providing you a service, and we continuously go and update and deliver improvements to that service all the time. We want to proactively address your needs. If there's a problem, we'll go fix it before it becomes an issue for your application. If you have a feature request to make your application more successful, we have the process and systems in place to go respond to that more effectively. And we do all this one step at a time. Our ultimate goal is to provide you a high level of SLA, so there is no disruption to your environment. And we do it in very bite-sized chunks. We're managing risk for you and taking care of all the work for you. So we're doing upgrades of software for you. So how do we get started on this? I mean, this comment came up a little bit earlier. Are we building microservices? Yes, we're building microservices. I think this is a pretty common buzzword these days. But really, what it boils down to us is a separation of concerns. You have to architect your system in a way that allows you to go and build, test, and deploy improvements to each part of the service independently. This allows granular SLAs and ultimately reduces risk for delivering large amounts of change one piece at a time. Second piece of the puzzle is the process. It's a very agile, quick iterations on design, prioritization, design, build, test, and then update the service. And all of this is done in the order of weeks as opposed to months or years. The thing that enables this rapid process is really our continuous integration and deployment pipeline. So this is a big part of how we do engineering, and this is a big part of how we successfully provide a service to our customers. Any change that's made by any engineer is instantly put through the entire battery of unit and functional tests that we have built over time. Once that change is validated by these tests, it's integrated into our mainline code. Once in that mainline repository, we run through another series of tests and advance that change through a series of qualifications that ultimately get rolled out to our entire fleet and the field. There's several advantages of this approach. First and foremost, on the continuous integration side, we're constantly updating changes to a single repository. So when we find a bug internally, we have a clear history so we can quickly go and address it. We're constantly adding new and new tests to this environment, so we're continually hardening this product. As it moves through the different stages of the pipeline, all of these are exact mimics of customer environments out in the field. So we're able to go and progressively run additional layers of tests as changes propagate through the pipeline. All of this has to be automated. There's no human involved in this. The last human action is a commit. So I, as a developer, go and make a change, submit my change. Once it's qualified, it goes out at a customer. If it bounces back, I have all the data to go and fix the bugs and go and submit a new change. Jeff talked about this earlier. We're delivering a service, and it's all a single team. This is another key. It's the same engineers building, testing, and supporting the service that we built. A big part of the agility comes from our simulation environment. This is something we emphasize from day zero. And what we have essentially built is a Docker simulation of our data center. So I can test this 200 terabyte appliance or something larger on this laptop. And this was a huge commitment early on, and it has paid off in spades, because this gives me the ability to go and turn around changes on the order of minutes and hours as opposed to days in a traditional approach. Let me just talk about some of the results with this approach. Every change that I make, it goes through at least 2,000 hours of machine testing over the course of a week. To date, we have deployed over 16,000 service upgrades to our customers out in the field. We've been delivering changes throughout this year on a weekly cadence.
When did you start?
We've been working with customers for 18 months at this point. New features, they don't come every 16 to 18 months. They come every 2 weeks. That's what we've been averaging so far. And when feature requests have come in from our customers, we've been able to quickly incorporate them and deliver them on the order of weeks. Let me talk about a couple of examples of building large-scale hard problems with this approach. The first one is a completely under-the-covers change of our primary object index data structure on disk. And the other one is a pretty complicated feature that's usually talked about in the networking world of quality of service. But increasingly, it's becoming more and more common and desired in the storage and infrastructure space in general, where you have many different workflows running in consolidated infrastructure. The common theme through both of these was we were able to take a large problem, break it down into bite-sized chunks, process those changes, develop those changes, and deploy those changes piecemeal. Through this entire process, through all the different deployments that it took, we had full observability and full reversibility, all managed through our cloud management plane that Jeff talked about earlier. If you guys want to dig into any of these, I'm happy to go over them either now or over drinks later. But the key was that these are things that usually take years to go build, and they create a high amount of risk in adoption. But we were able to go do all of these non-disruptively as a service for our customers. So just takeaways I want to wrap up with are, again, the advantages to our customers, which is that we're able to go and make big changes and respond to customer requests all rapidly with a high amount of confidence because we're managing all the changes and all the services for our customers.